Hello there, students. Welcome to Chapter 6, Section 3, Solving Systems Using Elimination. This starts on page 378 in your book. And I'm going to talk you through just 3 problems here, but they're long enough. It's going to take quite a bit of time. And it's another method, a new method to solve a system. And I find that often students like this one sometimes the most. You'll need to be able to show me all 3 methods. You've learned graphing by finding the intersecting point of 2 lines. You've learned substitution, where you solve for a variable, replace it, solve for the other variable, and have your solution. And elimination, which I'm going to show you today here. So please get all this copied on your notes, as well as your name and the date. And we will get started. This particular question is asking you to find this solution to this system right here. And you'll notice none of them are solved for y. Now we could use this by using substitution. We could solve it rather, and we would have to solve for one of the variables. And this one would be really ugly because we would have just some crazy fractions there. We'd have, oh gosh, we'd either have 17 over 2 or 17 over 5. So substitution on this particular problem would not be a good choice, but elimination actually works out pretty simple for us. Let me demonstrate. Go ahead and recopy the problem in the middle here where we'll show the work and make some notes. And hit pause as you need to do that. Here is the key to elimination right here. In order to do elimination, you have to have matching variables that have opposite coefficients. All right, matching variables S would have been better there. You must have matching variables that have, I can't type apparently, that have opposite coefficients. And this question has that for us. All right, 5y and negative 5y are opposite coefficients. They're both 5, but one is positive and one is negative. This is what you're looking for. Same number, but opposite signs on the same variable. Now, it can be the x, but you notice the x, that's not the same. So this is the magic thing right here, that 5y and negative 5y. Because those are opposites, we can do a new trick to solve this question a lot easier than using substitution. All we're going to do is we are going to, I'll make a note right here. Once you have that, you're just simply going to add like terms in both equations, straight down. You'll see how fast we can actually do this problem really fast. I am going to add, just like this, I'll draw the red line, I'm going to add straight down. Okay, I'm going to add the like terms. 2x plus 6x gives me 8x. Now watch what happens here. Positive 5y minus 5y, so positive 5y plus negative 5y, that's 0. So that's nothing. Now I have 17 plus negative 9, that's 8. So I have turned, by using elimination, I can see that 8x is equal to 8, and I can simply solve that by dividing by 8, and I get x equals 1. Guess what? You just found your first variable. There we've solved and we found that x is equal to 1. All right, now the only thing left to do, remember since we're solving a system, you have to find both the variables. You do have to substitute here. Okay, substitute to find the other variable. And at this point, it doesn't matter which one you choose to substitute into. So I'll pick the first one, I guess, 2x plus 5y. I'm going to replace the x with a 1 because x is equal to 1. So I'm going to substitute that in there, and I'm just going to solve this equation for y. That's really simply not much more than solving a basic 2-step equation. So 5y, that's just 2 there, right? So I'm just going to go ahead and subtract 2 from both sides. And I have 5y is equal to 15, it looks like. And then I'm going to divide by 5. And I need to scroll down the page just a little bit and get y is equal to 15 divided by 5 is 3. There it is. So my solution to this system is the order pair 1, 3. That worked out real nice for me there. And that's it. That's all you have to do. Unfortunately, it's not always that easy because sometimes that variable, the initial equations may not be matching opposite coefficients, like it's going to happen in the next one, I'm sad to say, but that's about to happen here. So as we go ahead and look at the next problem, here we have this, whoops, I meant to put my shade up here so you wouldn't see that. And as I continue to look at this problem, I'm a little uncomfortable with the amount of time I have and how much I might need to explain on this. So I'm going to stop this one, make this a short video, and just do a new video for this problem here. I just think that would work better, and I won't feel like I have to rush as much. So part 2 is about to come.